Hello, this is Ms. DB. In this video we are going to look at an introduction to sequences and talk about how we form them. And then we'll look at, later in this week, we'll look at arithmetic and geometric sequences and series. So a sequence is just an ordered set of numbers. Every number is called a term. And the first term is called a sub 1. You pronounce that a sub 1. And then we can write rules for sequences. So we can write rules two ways. We can write a recursive rule, which says that take the number before it and then do some stuff to it. So this recursive formula is that to find any term, you would take 3 times the number before it minus 2. So that's the rule. N denotes whatever the term you're looking for is. So in order to find the second term, you would take 3 times the first term, which is 4, and then minus 2. So for the recursive rule, you need to know the numbers in order of the terms, and you need to be able, you can only find the next term from that. So to find the third term, we take our answer from the second term, multiply it by 3. 3 times 10 is 30, subtract 2, you get 28. So you always use the previous term to compute the next term. That's called the recursive formula. And so you're going to do that for the first few problems here. You're going to use this recursive rule. And there'll be different rules, and sometimes you'll have to find them, and sometimes they'll be given to you. So let's look at number 1. The first term is given to you, a sub 1 equals 4. And then they also tell us the rule. The rule says to take 2 times the term before it, and then minus 3. So they have to give you the first term in order to start the process. So they're giving us the first term is 4. And then we would take 2 times 4, which is 8, minus 3 is 5. And then for the next row, you would take 2 times 5 minus 3, so 10 minus 3, and you put that answer here. And then for the fourth term, you would take 2 times whatever your answer here is, and then minus 3, and that'll get you that answer. So you always have to use the term before it, and then you just write them all out with commas in between them. Alright, let's do this for, you can use this table over and over if you want to erase it, or you can copy it, and or you can do them without a table if you prefer, or you can write tables on your worksheet, on your own paper. Let's do number 5, because it looks kind of hard, doesn't it? So it says that the first term is 1. I'm going to put that in, that the first term is 1. And then to find the next term, a sub 2, I'm going to take the first term, that would be 1, times the first term plus 1. So I'm going to take the first term times the first term plus 1. So 1 times 2 is 2. So now my next term is 2. So I have, the rule again is I take my first term, or my term before it, which is 2, and then I have to take that term before it and add 1 to it. So 2 plus 1 is 3. 3 times 2 is 6. Okay. Now I'm going to use my rule again, and I'm going to take the term before it, which is now 6, times the term before it, which is 6, plus 1. So I have 6 times 7, which is 42. And then I have to do it one more time. This one's going to be big. I have to take my term before it, which is 42, and then I have to multiply that by 42 plus 1, which is 43. So I need 42 times 43. 1806, 1806. So these are not necessarily arithmetic or geometric sequences, they're just some other kind of sequence, and they're giving you the rules to use them. So for number 5, I would write my first 5 terms as 1, 2, 6, 42, and 1806. And you'll do that for each of them. So again, you can either erase the table each time, or you can copy and paste it, or do it on your own paper. Okay, so because the way of that way always relies on us finding every term in a sequence before the term we're looking for, there's also an explicit formula where you don't have to do that. The explicit formula lets you find any term of a function. You don't need to know all of them in order before that. So let's look at using the explicit formula. And there's specific explicit formulas for arithmetic and geometric sequences, but any sequence can have an explicit formula. If you know what it is, then you can use that to find the missing terms. So here's our explicit formula. It says that a sub n is equal to n minus 2 to the nth power. So I'm going to use this table to help me fill this out. My first term, n would be 1, so I have 1 minus 2 to the 1. So I replaced n with 1 both times I saw it. So that's the same as 1 minus 2 to the 1 is just 2, so I get negative 1 for my first term. Now I don't need to use that negative 1. This is not a recursive formula. This one is just based on term numbers. So for my second term, I'm going to replace n with 2. So that would be 2 minus 2 to the second power. So I'd have 2 minus 2 squared is 4. 2 minus 4 is negative 2. Now don't do 2 of them and then say, oh, the pattern is negative 1, negative 2, negative 3. You don't know that yet. So next we're going to replace n with 3. So 3 minus 2 to the third power. So 3 minus 2 to the third power is 8. So 3 minus 8 is negative 5. And then you'll keep going until you're able to complete the first 5 terms using this explicit rule. Make sure that when you do this, you're doing the power part first before you're taking the number minus that power. You would not do 3 minus 2 and get 1 to the third power. You'd have to do the power part first and then take the first number minus that. Alright, so you're going to use the explicit rule that's given to you in order to do these. You can also use Desmos to generate a sequence, and there's a short video here showing how to do that if you want to give that a try. That's optional. Let's look at the explicit rule for number 10. So we have a sub n is equal to 2 to the n minus 2. So I'm going to just write out each of my, so a sub 1, I'm going to use my subscript tool in Word, would be equal to 2 to the power of, use my superscript, my exponent key, and I need n, which is 1 minus 2. Okay, and that is equal to 2 to the 1 minus 2 is negative 1. And remember your rules for exponents. If you have a negative exponent, you can bring the base down, and then you can have a positive exponent. So this is the same as 1/2. So 1/2. Now I need to find the second term. So that will be equal to 2 to the n minus 2 power. So n this time would be 2, and 2 minus 2 is 0. So it's 2 to the 0 power, but anything to the 0 power is equal to 1. So my second term is just 1. Then I need my third term, and you would keep going until you have 5 terms, which is what the problem asks you to find. So this would be 2 to the 3 minus 2. And 3 minus 2 is 1, so this would be 2 to the 1 power, but that's the same as just 2. Put the fourth one on here as well. So that would be equal to 2 to the 4. I'm just making sure I was doing it in the right order. 4 minus 2, and that's equal to 2 squared, or 2 to the second power, and you'd have one more to go. We'd have a sub 5 would be equal to 2 to the 5 minus 2. And then you would finish that problem out to see what your last term would be. That one is a geometric sequence, but that's okay. And then this, I think, is an arithmetic sequence. Okay, so here's the next part, is a little bit more work. You're going to try to find the rule to match up to what the given terms are. So it's easiest if we know that it's arithmetic or geometric, because then we can use this rule. So arithmetic is this rule here, and exponential sequences are the same as geometric sequences, so you can use this rule here. So here's the explicit formula for arithmetic and for geometric. Now, not all sequences are arithmetic or geometric. Some of them you just have to try to figure out what the rule is. Like, maybe the rule is multiply by 10 and divide by 2, or I don't know. There's different ways of finding them than arithmetic or geometric. But in number, I shouldn't say 1 through 4, in these first ones, these are all going to be arithmetic rules. So you're going to be able to use the rule for linear or arithmetic, which is right here, for numbers 12, 13, 14, and 15. So the rule says that we can take, we're going to need the common difference, and we need to know the first term, and then the n is just what number term you're looking for. And in these, we're not looking for a term, so that's going to be, that n will stay in our rule. So the first part is finding the common difference. So the common difference between, how do you get from 3 to 1? Well, you can subtract 2. Is that the same in each of them? Do I subtract 2 every time? Yes, so the common difference is subtract 2. And that's how I know that it's linear, if that common difference is the same for all of them. The first difference is the same for all of them. So d is equal to -2. The first term is 3, we just get that from the problem. Now I'm going to use the formula, because now I know it's arithmetic because I had the same first differences for all of them. They were all subtract 2, -2, -2, -2, -2. So the formula is a sub 1 is 3 plus n minus 1, leave the n, times the common difference of -2. I put the -2 in parentheses so it doesn't look like I'm subtracting 2 from the n. That's my rule. That's all you have to do for these first 4 problems, is figure out what that rule is. And you could check it by plugging in, like, let's see if the third term equals -1. So I'd do 3 here. 3 minus 1 is 2. 2 times -2 would be -4. 3 minus 4, or 3 plus -4, is -1, so it does work for the third term. And you could check it with the other terms too and make sure you get the right sequence. All right, so these are all going to be done that way. You're going to be writing the rule in this form. N will stay in each of them. You'll be replacing the a sub 1 in the d. All right, now these ones are not going to be arithmetic. They're going to be something else. So it might be arithmetic or geometric. It might be arithmetic, or it might be something else. It looks like there's no nothing else ones. So let's see if, here's the geometric rule, which you've used as exponential rules as well. So let's see if 16 works out to be geometric. If it's geometric, and we'll look more at that later this week, geometric sequences, then you'll have the same, the first differences won't be the same, the second differences won't be the same, but the ratio of the second differences will be the same. So first we have to decide if we can use this rule. So the first differences is what you get to the next term. So 5 minus 1, or from 5 to 1, here I'll do it this way, 1 minus 5 is -4, 0.2 minus 1 equals -0.8, and then we would take 0.04 minus 0.2, and we get -0.16, and then our last one would be 0.008 minus 0.04, and that is, okay, so these are the first differences. And now we need the second differences, which means we subtract these. So we're going to take -0.8 minus a -4, which is the same as +4, so that's 3.2. And then we're going to take negative 0.16 minus negative 0.8, so that's 0.64, and then we're going to take minus 0.032 minus 0.16 negative. I hope my calculator kept up with my negative signs here. 0.128, and those are not, so this is not a quadratic function, which is what, if those were all the same, would show. But we learned when we learned about exponential functions earlier this quarter that if the ratios of these are the same, then that means it's exponential sequence, or exponential function, which is the same as a geometric sequence. So we need to take 0.128 over 0.64. We only have 3 numbers to work with. And then we need to take 0.64 over 3.2, and we should get the same number for those if this is exponential. Divided by 0.64, that's 0.2, and then 0.64 divided by 3.2 is also 0.2. So the ratio of the terms or of the second differences is 0.2. So this indeed is a exponential function which matches up with a geometric sequence. And then from there we can use this formula. So when you get to the geometric sequence, they'll be given to you as geometric, so you won't have to do this again. It's just this problem. Because it looks like number 17 looks arithmetic, so I did most of the work for you there. And then you'll fill in the first term is 5, and the ratio is, the common ratio is 1 divided by 5, which is 0.2. And then it's the same as what we got here. And then a sub n will be found by using a sub 1, 5, times 0.2 to the n minus 1. And again, we'll leave our n's in the formula because we're just writing the rules here. All right, so I hope that helps you finish this worksheet on sequences, and have a wonderful day.